welcome back. Let me continue where I have left you in the last class, where I was explaining why x plus 2, even if it is satisfied with a single value, can be said as an equation. So I was explaining about 2D and 3D, and after understanding 2D and 3D, you could understand why this x is equal to 2 also an equation. So let me explain 3D and 2D for you. 2D means when any figure represented in two-axis system. What is two-axis system? This is nothing but the axis x-axis and y-axis. Okay. When a figure is represented in the form in a platform where two axes are there, x-axis and y-axis, what is the property of this axis? They intersect each other at 90 degree, means those are perpendicular to each other, and this we called y-axis, this we called x-axis. Okay, so they are intersecting at point some point, and they are perpendicular to each other. This is the property of this. In this plane or in this structure, if I represent any figure, that would be two-dimensional figure. That means I will get only two dimension of that figure. That means if I take any point here, it has to be one x component and y component to reach this point. So that's why this having only x and y coordinate by which I can represent this point, and this point where they are meeting each other, that would be the 0, 0 point, where x value would be 0 and y value would be 0. So this as a whole is a two-dimensional surface where any object I will represent it in the form of two dimension. So you can understand, in this universe, anything which I can hold or have any existence on this universe always have three dimension. You cannot avoid any figure without this three dimension. That means that should have width, length and breadth. All three should be there. When those figures are represented in the form of 2D, in 2D plane, then I am assuming I am seeing it from some direction, and assuming that is being played in two-dimensional. So two-dimensional only is the representation of any figure on 2D, but actually this is a 3D figure. So I should know the 3D figures also, so then I can understand the complete shape of that object which I am putting it in a 2D figure. Okay, so the 2D always have two dimensions, x and y. So line segment, which could be any part of any figure, also can be represented. Let's say I am taking this. So this line is a combination of dots. Okay, so each dot having some values. So if I join all the dots, it will give a line. Now come back to the example. Now this x is equal to 2 means, if I assume this is being drawn on this plane, so x is equal to 2 means from here, if I divided this x-axis in equal unit division, And the same on the y division. So x from here, from 0, 1, 2, if I draw x is equal to 2, this will be a line itself. That means in this line, the x value will always be 2. If I go anywhere, if I take any point here, x will be 2. But what varies here, that means y is a function of something. Okay, y is a function of something that does not depend on x. So that means taking this line, y could be anything. Y could be positive this side, negative this side, okay, but x is always 2. So this always represent an equation where some variable which is not written here or expressed here will be always be there to represent it as a line. So x is equal to 2 if I say a line where x value may differ in this line, but y value may differ in this line, on this line, and x is always 2. So you have understood why I am saying x is equal to 2 is an equation. Now I will also can say that x is equal to 2 can also be a equation in case of 3D. So in 3D system there should be 3 axes. In 2D there is only x and y. In 3D there will be x, y and z axis. So if I take this is x and this is y and this is z, and they are mutually perpendicular to each other. These axes are drawn such a way they are perpendicular. So that means x and z will be 90 degree. If I take this also a 90 degree and this also a 90 degree. So that means no third axis. That means no third axis. That means no third axis lies on same plane. Let me explain it. If I say x and z forming a plane, this plane, x will not be on the same plane. Or if I take this as one plane, x will not lie on that plane, and similarly the other two, if I take x and y, then z will not lies on where x and y lies. So for 3D, no two axes lies on same plane and they are mutually perpendicular. So up to this you can understand, you might have understood. Okay, now x is equal to, if I want to represent in 3D, now if I divide x axis equally and z axis, y axis equally, so x is equal to 2 could be something which will lie on where I will get, if I take this like this, then x is equal to 2 for this. If I take in reference of y axis, x will be there where y varies, and if I take this, then it will be like that, x is equal to 2 against z axis, something like that. This is also true where x is equal to 2 but z varies. So I have to arrive somewhere. I will get some plane where any point on this plane where x value will be 2, but x also varies, z also varies. Understood? So in this plane where that could be a plane where x is equal to 2 lies but z and y varies. Okay, so x is equal to 2 is an equation which can be represented in 2D and 3D also, but it is an equation where z and y can be vary Z also is not a function of x in case of 3D. So this is also true for 3D, this is also true for 2D. So I think you have understood what I am explaining here. So in my next class I will come with more kind of concept and problem to explain it, so that the things will be more clear. And kindly go through the chapter wise. Otherwise, if you pass one chapter and read another chapter or follow another chapter, you may not be able to understand, or continuity will not be there. So I request you, kindly go through chapter wise, chapter 1 and chapter 2 likewise. Then it will be interesting for you to learn new things. I suppose it is not very common to in any textbook or in schools also. I think definitely will help you to understand or clear a concept much. Thank you for now.